In this lecture, we will discuss about continuity and differentiability for complex variables. So first we start the definition of continuity. So when we have real variables and complex variables, so we define the continuity and differentiability. So first we start the continuity for complex variables. So let we take as let z is equal to x plus iota y be a complex variable, and we take w equal to fz. So w equal to fz be a complex function, or we can say that be a function of complex variable. So we write down this as be a function of complex variable, be a function of complex variable z. So then fz. So this function fz is called continuous. Function fz is called continuous at point z is equal to a. If we have some condition, means epsilon which is positive and delta also positive, nearly about zero, be the positive quantity, such that absolute value of z minus a, which is less than delta, implies that fz minus fa, which is less than epsilon. So we take as here is a and this is delta, and the points lie in this. So now this is the Cauchy definition. So this is the Cauchy's definition for complex function. Now we write down as if fz is called continuous. Fz is called continuous at z equal to a. If we write down as limit z tends to a into fz gives us fa for each path of variation. So we can change any path, but we get the value of z. So when we change any of the path, so we get a fa. So this is the another definition. Basically, this is definition is known as the arithmetical definition. Now we move to the differentiability. So second definition is differentiability. So next definition is differentiability. So for proving differentiability, the function fz is called differentiable at z0, z0, if limit we take delta z tends to 0, f of z0 plus delta z minus f of z0 upon del z exists uniquely for each path of variation. We change any path, but we get the existence of the function this at delta z tends to 0. So the function fz is called differentiable. So now we can write down this as f dash into z0 is equal to limit delta z tends to 0 f of z0 plus delta z minus f of z0 upon delta z, or we can write down as f dash z equal to limit delta z tends to 0 f of z plus delta z minus f of z upon del z. When we replace this z by 0, so when we put z tends to 0, so this we can write down as f dash 0 is equal to limit delta z tends to 0 f of delta z, f of delta z minus f of 0 upon delta z. So now when delta z replaced by z, so this can be written as f dash 0 is equal to limit z tends to 0 f of z minus f of 0 upon z. Okay, so then function is said to be differentiable. So we get the unique value. So uniquely each path of variation. We change any of the path, that means either we take a straight line y equal to mx, y, or any other. We can take a parabola y square equal to 4ax, etc. But we get the same value. That means exists the limit. So we can say that the function fz is differentiable. Otherwise, question 1, if fz is equal to xy square into x plus iota y upon x square plus y raised to the power 4 when z is not equal to 0 and f0 is equal to 0. So limit z tends to 0, fz minus f naught upon z is equal to 0 for a straight line or is not equal to 0. So is not equal to 0 in any manner. So to check the derivative of this particular function is exist or not, derivative exist or not. So for checking the derivative f dash naught is exist or not, so we take first case. So we will discuss this case by case. So that means we can take case 1. So case first, we take a straight line. So we take a straight line. So that is y equal to mx. So we take towards to origin. So now let z tends to 0. Z tends to 0 along straight line y is equal to mx. So this can be written as z equal to x plus iota y. This can be written as x plus iota or y is mx. So when we take as z tends to 0, so when z tends to 0, this implies that x tends to 0. X tends to 0. So now limit z tends to 0, f of z minus f naught upon z. So which implies that we take a limit x tends to 0. So what is the value of fz? So the value of fz is defined as xy square into x plus iota y. So we write down as x y square into x plus iota y. So we also replace this y. So we replace this y directly by mx. So we write down in this step. So x y square. Y square means m square x square into x plus iota y mx upon x square plus mx raised to the power 4 because we have a in denominator x square plus y raised to the power 4. So this is fz when z is not equal to 0. So minus 0 upon z. So upon z x plus iota mx. So the value of z is x plus iota mx. So this x plus iota mx to this x plus iota mx will cancelled. So this gives us, so we can write down as limit x tends to 0. So m square into x cube upon. So here we write down as x square plus m raised to the power 4 into x raised to the power 4. So this we can write down as limit x tends to 0 m square into x cube upon x square we take as common. So 1 plus m raised to the power 4 into x square. So m raised to the power 4 into x square. So this we can write down as, so this x square to x square, x cube cancelled x times. So we can write down as limit x tends to 0 m square x upon 1 plus m raised to the power 4 into x square. So when we put a limit x tends to 0, so this can gives us 0. So this gives us 0. Now, so we have taken this as from about a line y equal to mx. Now we change any path of variation. So we do the change. So in case second, so when we take any path, so that means we get the same results. Okay, so when we take a let z tends to 0, so we considering along parabola y square equal to 4ax. So we take this as y square equal to 4x be the parabola. So this is y square is equal to 4ax. So we can write down as z tends to 0, y square equal to 4ax. So z equal to, we have x plus iota y. So we write down as x plus iota of y value is 2 root ax. So y 2 root ax. So when we take z tends to 0, which implies that x tends to 0. So z tends to 0 to x tends to 0. So now we take as limit z tends to 0 function fz minus f naught upon z. So this we can write down as limit x tends to 0 fz. So value of fz, so x into y square. Y square means 4ax into x plus iota y. So iota y means 2 root ax, 2 root ax upon x square plus y raised to the power 4. So y raised to the power 4 gives us 4 4 just 16 a square into x square minus f naught. F naught is 0 upon x plus iota y. X plus iota y 2 root ax. So this x plus iota 2 root ax to uh, x plus iota 2 root ax cancelled. So this gives us limit x tends to 0. So 4a x square upon x square plus 16a square x square. 16a square x square. So now we can take x square common from denominator. So this gives us x tends to 0, 4a x square upon x square, so gives us 1 plus 16 a square. So this a x square to x square cancelled. So when we have apply the limit x tends to 0 in this function remaining terms, so 1 plus 16 a square, so this is purely constant. So gives us 4a upon 1 plus 16 a square, so which is not equal to 0. So which is not equal to 0 from first line. That means we can take any path. So each path of variation we get the same result. So that means in first path we take as y equal to mx gives us 0. But when we take a parabola another curve, so which gives us the not equal to 0. So that means constant value. So we can say that the derivative of this does not exist. So hence we say that hence f dash 0 does not exist. So function does not exist. Now, similar question we will take. So again, question number 2. So function fz, which is defined as x cube y into y minus iota x upon x raised to the power 6 plus y square when z is not equal to 0 and function is defined as f0 is equal to 0. So limit z tends to 0, fz minus f naught upon z is equal to 0 when straight line and not equal to 0 in any manner. So check the function f dash not exist or not. Exist or not. So same thing we will do here also in previous as per previous question. So now we take the cases. So we take the case first. So in case first, we do the same thing. We take the straight line. So we take the straight line y equal to mx. So we have z tends to 0. So z tends to 0. So we write down along a straight line, along a straight line y equal to mx. So along a straight line y equal to mx, so we write down the same thing. So z is equal to x plus iota y. So this can be written as x plus iota into mx. So when z tends to 0, which implies that x tends to 0. So z tends to 0 means x tends to 0. Now we take limit z tends to 0 fz minus f naught, fz minus f naught upon z. So this can be written as limit x tends to 0. So the value of the function value is x q y. So we write down x q y. Y means mx into y minus iota x upon x raised to the power 6 plus y square means m square x square minus f naught is 0 upon z. Z is x plus iota y, x plus iota into mx. Now, we simplify this so we can write down the limit x tends to 0. So this can be written as m x raised to the power 4. X raised to the power 4. So in this term, we can take minus iota as common. So minus iota is common. The first term will be x or I square is minus 1. So we can write down as minus minus plus. So I mx upon x raised to the power 6 plus m square x square into this denominator x plus iota into mx. So this term to this term will cancelled. So that means limit x tends to 0, x tends to 0. So minus iota m into x raised to the power 4 upon x raised to the power 6 plus m square x square. So when we put x tends to 0, so in numerator having x term, so this gives us 0. So this gives us 0. Now we move to the further, so that means case second. So when we move to the case second, so in previous case we consider parabola, but in this case we consider as hyperbola. So in consider that means second curve in this way. So we consider as y equal to x cube. So now when z tends to each path of variation, we can change any of the paths. So you remember this thing, z tends to 0. So we are considering this along y equal to x cube. So y equal to x cube. So we can write down as z equal to x plus iota y. So x plus iota y means x cube. So when we take as z tends to 0, so this implies that x tends to 0. So this implies that x tends to 0. Now we write down a limit z tends to 0, f of z minus f naught upon z. So this can be written as limit x tends to 0. So first term is x cube. So this is x cube into y. So x cube into y. So y is also x cube into y. X cube minus iota x upon x raised to the power 6 plus y square. So y square means x raised to the power 6 minus 0 upon x plus iota y. Y means x cube. So we simplify this. So limit x tends to 0. So here we have x raised to the power 6, or same minus iota we have taken as common. So this can be written as x plus iota into x cube. So upon x raised to the power 6 plus x raised to the power 6 means 2x raised to the power 6. So we write down directly this. So this gives us uh, 2x raised to the power 6 into x plus iota x raised to the power 3. So this term to this term cancelled, and x raised to the power 6 to x raised to the power 6 cancelled. So we have the remaining term as x tends to 0 minus iota upon 2. So minus iota upon 2. So this is purely constant. So when we apply limit, so give the same minus iota upon 2. So the when we have taken the first curve, which is y equal to mx line, gives us 0. But when we take the second path, so which gives us minus iota upon 2. So it means that both results are different. So we can say that derivative does not exist. So we need the same in each path of variation.